than the other two. Most of the utilities that we need to build the airplanes have been located under the factory in these tunnels. This way, when our facilities people need to work on the systems, they don't have to disrupt anybody building airplanes on the floor above us. The tunnel itself is 1,658 feet in length. That's 510 meters, or if you happen to be a jogger, it's about 1/3 of a mile. Now, a number of our employees that like to run for exercise come down here during lunch and after work. I don't see anybody at this time, but they do show up rather quickly, so I would like everyone to stay to this side of the tunnel, both going down and coming back. We'll let the runners have the other side. It seems to work. Well, we are now standing in the world's largest building as measured by volume. Inside of our factory building, there are 291 million cubic feet of space, or 8.7 million cubic meters. It is a bit difficult to deal with anything that large, so we'll break it down a bit. The roof of this building covers about 65 acres of floor space, equal to about 2,700,000 square feet. And in that much space, we could fit 57 football fields, or 10,000 average-sized American houses. The building itself is 115 feet in height, 35 meters, or 11 stories. At this time, we are standing on the 4th story.
Well, we started building our factory in 1966 specifically for the 747 program. It took 23 months to complete, and in 1979 we created an additional manufacturing bay specifically for our 767 program. This building does have a very energy efficient design and has no central heating or air conditioning system. In fact, if you look at the ceiling, you'll notice it's not even insulated. All of the heat in this building comes primarily from the lights, but also from office space areas. These cranes can travel anywhere inside of our factory building. You might also notice there is an operator that does sit in each crane. The area that we are overlooking right now is what we call 747 Major Assembly. It's where we start taking the parts and pieces that come to us from the various suppliers and subcontractors and start assembling them into larger pieces that will become our complete aircraft and final assembly. The wing assembly area is directly ahead of us and off to the left. And those wing parts again are built by the Boeing Commercial Airplane Company in Auburn, Washington. Parts are shipped in those long yellow containers that we passed on the way in. And we do a little more machining work to the parts, and then we assemble them by riveting into the complete wings you see directly ahead of you. Another part of the aircraft built by the Boeing Company is that nose of what we call the 41 section. We have an example to my right and also to our left. Now, these parts are built by the Boeing Military Airplane Company in Wichita, Kansas, and that is a different division altogether. The passenger cabin of the airplane, the body or what we call the fuselage, is built by the Norfolk Corporation in Hawthorne, California, and that is a different company altogether. The tail or empennage is built by LTD Bot in Texas. The pounding noise you hear is the sound of rivet guns. Virtually all of the airplane is riveted together. There is almost no welding in an airplane. If you'd like to follow me around this tooling crib, I'll show you where this all goes together in final assembly. This is our current 747 final assembly line. This is where we take all those parts and pieces you just saw and bring them together to form our complete aircraft. We do have 3 of these large assembly bays at the Everett site. The center bay, that's where perhaps you can see the Japan Airlines airplane tail sticking up directly ahead of us. There's also a 747 assembly line, but at this time we are not using it to produce new airplanes. Later this year, however, we are going to close this assembly line down and move production of our 747 to that center bay. That's because in December, again, we start final assembly of our 747-400 model. That particular airplane is going to have a 6-foot wingtip extension. If you look down at the wing directly below us, I think you get a good idea why we need difficult to see from this point. Basically the same as the 747 operation. Smaller pieces is a major difference, and it does go a little bit slower in real life than it did in the film. The final assembly consists of 4 distinct stages. The process starts to our far left in the first position known as wing to step join. Now, unfortunately, there are no parts that actually passes through the center of the airplane. The wings and wing center section also form the airplane's fuel tanks, and at that point we test the assembly to make sure it will not leak fuel later on. Now the cranes move the wings forward to the next position known as wing. We must also attach the landing gear now because the airplane is too heavy for our cranes to pick up, and we'll tow it from this point forward. The last positions in the factory are off to the right. We simply call those positions final assembly. It is at that point that we complete the airplane. We begin our ground testing of the various systems. Airlines do save a substantial sum of money by delaying that purchase until the latest point possible in final assembly. Now you may have noticed the airplanes have a greenish color to them at this point. That is a temporary protective coating. It's a green vinyl material that is applied to these parts at their point of manufacture. This green vinyl will protect the skin of the aircraft from corrosion and abrasion damage until the airplane has been completed and delivered to its customer. Another thing that comes up to 8 months from the time we start building the parts to delivery to the customer. We do work 3 shifts at the Everett site, and including our engineering and administrative staff people, we now have about 15,000 employees in the Everett division. In the Seattle Puget Sound area, we just passed 87,000.
Oh, cute. Right now I'm having. Yeah, look who's in the front now. Oh, that's why did we have
So these airplanes are essentially complete when they roll out of the factory. There still is about 30 days worth of work over this bridge that crosses the freeway. For a number of years we did that during the daylight hours. Well, the Washington State Patrol finally asked us to please stop it. Since we were causing them some traffic problems as people came over the crest of the hill on the freeway and saw what they thought was a 747 sideways in the road. So we do that at night now and everybody does appear to be happy. Painting an additional 300 to 400 pounds of weight. On the 747, it jumps up to 600 to 800 pounds of extra weight. Some of our customers do leave the paint off their airplanes. Good examples are Northwest Orient and American Airlines. This, of course, gives them a lighter airplane, therefore a more fuel-efficient airplane. But there is a trade-off because paint protects aluminum from corrosion, and airliners that are not painted do have to be maintained more carefully. Now, once the airplane is painted, bring it to the fueling position to our right. We do not like to have a fuel or previously fueled airplane in the hangar, due to a fire danger, of course. If the airplane has been fueled, all the fuel must be taken off, and the entire fuel tank must be flooded with nitrogen gas in order by usually 10 to 15 hours on 4 different test flights prior to delivery to the customer. Most of them going field in Seattle because that's where our flight test organization is headquartered. We have a couple 747-300s, one for Cathay Pacific and another one for Swiss Air. Swiss Air was the first customer to order our 747-300, and their first one entered commercial service in 1982. Now this airplane has got an extra heavy coating of that green vinyl material that we talked about. That's not paint on there, that is all a temporary coating that will have to be removed prior to painting of the airplane. Nice color, but it has no resistance to hydraulic oil, so it can never be used as a permanent coating. Another 747-300, we've recently certified the heaviest takeoff weight ever built into a 747 on this aircraft. Maximum takeoff gross weight, as it's called on that airplane, is 871,000 pounds. Now we jump down size again to our 767 program. These are a couple 300 models for Delta Airlines. The 300 is a newer version of our 767. It's 21 feet longer than the original 200 design that first entered commercial service in 1982. Dave Field, by the way, is off to our right at this time. It is a 2,000-foot runway, or I should say 9,000-foot runway, or 2.8 kilometers. And we have another 747. This is a 200 model for Japan Airways. That airplane has also been returned for some extra modification work. Okay, the tarmac or apron going out to the runway is directly ahead of us on the north end of the field. Off to our right, you can see the remnants of our 767 static test. That's the airframe sitting there with no tail on it. Now that airframe was taken off the assembly line. Instead of delivering it to a customer, however, we tried to break the wings off of it just to see how strong they were. We couldn't do it though. We fastened the body down and applied 1,200,000 pounds of force to the wings. We had them bent up 15 feet 8 inches. They still didn't break. 67-300 extended range test airplane that just passed. We used that one, however, to certify General Electric engines. Now, there are 3 engines available for use on our 747s. For example, Thai International Airways. On the 747-300 for Thai International Airways, you might also notice that the wing trailing edge flaps are extended. They're in the very back of the wing. Those trailing edge flaps are generally retracted up into the wing during flight, but upon landing or takeoff, the pilot extends them as you see there. It increases the surface area of the wing, changes the airflow a bit, and allows 747s, by the way, have about 4.5 million parts in them if you count all the fasteners. 135 miles of electrical wiring, and the aircraft does hold a maximum of 55,000 gallons of jet fuel, which is very similar to kerosene. Some of the newer Rolls-Royce engines being developed for the 747-400 will produce up to 58,000 pounds of jet thrust each, and the 747 has 18 tires. That spreads the load over the runway more evenly, requiring a less thick runway surface.
And it also allowed the 747 to operate from here. We're not building that shorter SP model anymore. Visiting the state of Washington, couple nice weather stays.
For land.